We've all been there. You are staring at a problem that refuses to be solved. You try the same fix a dozen different ways, and every single one leads right back to a dead end. Take the story of a marketing assistant about to deliver a career-defining presentation. For 15 minutes, he sweats in front of the client, desperately pressing buttons and toggling settings on his laptop because the room's projector won't display his slides. He checks the software, he restarts the machine, he does everything except the one thing that matters, looking down to see he never plugged the laptop into the projector. Cognitive psychologists call this inattentional blindness. In a famous 1999 experiment, volunteers were asked to count basketball passes between a group of people. They concentrated so intensely on the ball that half of the viewers completely failed to notice a person in a full gorilla suit walking straight through the middle of the game. When we hit a wall, we assume we lack the intelligence or the technical skill to figure it out, but the failure usually happens much earlier. Our perception is flawed. You cannot fix a broken machine if your brain refuses to see half the parts. Master-level problem-solving requires shutting off the noise. That means actively ignoring internal anxieties about deadlines, as well as the external distractions in the room, so you can observe the raw data of a situation objectively. Before you look for what is wrong, you have to know what is right. You establish a baseline. Whether observing a complicated spreadsheet, a piece of machinery, or a person's behavior, you need a firm grasp of what normal looks like in that specific context. Once you know the baseline, you hunt for micro-deviations. You look for the slight pause in a coworker's speech, or the single line of code that looks out of place. This granular data provides the specific variables needed to crack the case. Without acquiring this unfiltered information first, any attempt to logic your way out of a crisis will be built entirely on false assumptions. With the right observations in hand, you can begin connecting them. This is the process of deductive reasoning, taking the effect you see in front of you and tracing it backward to find its origin. Imagine walking into your kitchen and finding a puddle of water on the floor. You could grab a mop, clean it up, and assume the job is done. Or you could look closer, notice a few shards of glass nearby, and figure out someone knocked over a drinking glass. You stop treating the symptom and identify the root cause. Analysts structure reverse engineering using a fishbone diagram. You write the problem at the head, draw a center line, and add angled branches for categories. Filling out these bones organizes chaotic information, mapping smaller factors to pinpoint one buried failure point. By anchoring every hypothesis in a documented category, deductive logic replaces blind guessing with a linear, undeniable chain of evidence. But eventually, even the sharpest logic reaches its limit. You will face a problem where the data is incomplete, the budget is impossibly tight, and the variables are too chaotic to map neatly on a diagram. In these moments, chronological evidence breaks down. Relying on convergent thinking, the pursuit of one single, logically correct answer, stops working. When you exhaust your logical options, you have to break the rules of the problem. You have to intentionally disrupt your own perspective. This requires divergent thinking. Instead of narrowing your focus to find the best answer, you deliberately fracture the problem to generate endless, unconventional possibilities. One of the best ways to force this divergence is through intentional constraints. In a 2015 study, university students were asked to find creative uses for 250 leftover sheets of bubble wrap. The group primed to think about having scarce, limited resources completely outperformed the group that focused on abundance. Artificially limiting your resources forces your brain to abandon its comfortable, default neural pathways. When you have no choice but to work with less, you forge new connections out of sheer necessity. You can also disrupt your perspective through inversion or reverse brainstorming. If you are struggling to make a project succeed, stop trying. Instead, sit down and map out exactly how to guarantee the project fails. Identifying those drivers of failure shows you exactly what to avoid. Constraints and inversions act as a psychological crowbar. They pry you out of your own biases and reveal obvious solutions that were sitting there the whole time. Sometimes, conscious brute force is entirely useless. To synthesize highly complex answers, you have to enter the diffuse mode, a relaxed, mentally detached cognitive state. The surrealist painter Salvador Dalí relied on this state. To harvest his brain's slow-moving theta waves, he used a technique called slumber with a key. He would sit in a chair holding a heavy metal key over an upside-down plate. The moment he began to doze off, his muscles would relax. The key would slip from his fingers, plummeting to the floor and waking him with a loud crash at the exact edge of unconsciousness. Albert Einstein engaged his diffuse mode through a practice he called combinatory play. When he was stuck on a difficult physics equation, Einstein would step away and pick up his violin. Sawing away on the strings allowed his subconscious to process the math in the background, combining completely different disciplines to trigger massive breakthroughs. Daydreaming, napping, and playing act as biological mechanisms for deep pattern recognition. The cognitive escalation follows a reliable sequence: observation, deduction, and disruption. By gathering the right data and forcing your brain to look at it through an entirely new lens, you realize there is no such thing as an impossible dead end. You are just looking at a puzzle that's waiting for the correct perspective.